The piston displacement is the volume of the fluid that all the pistons displace as they travel from bottom dead center to top dead center. It is the product of the area of the piston, the length of the stroke, and the number of cylinders of the engine. The equation is PD equals A times L times N. A is the area of the head of the piston in inches, L is the length of the stroke in inches, and N is the number of cylinders. Total piston displacement is usually expressed in cubic inches. Compression ratio. The compression ratio is the ratio of the volume of the cylinder with the piston at the bottom dead center position compared to the volume of the cylinder with the piston at the top dead center position. Intake stroke. On the intake stroke, the vaporized fuel which was mixed with air to attain the correct mixture of fuel and air, also known as a stoichiometric mixture in the fuel control unit or the carburetor, enters the cylinder as the piston travels downward in the cylinder. Stoichiometric mixture is equal to a mixture ratio of fuel and air which extracts the maximum amount of heat energy from the fuel. At the start of the intake stroke, both the intake and exhaust valves are open. This condition allows for a more complete and efficient purging of the exhaust gases in the cylinder, thereby helping cool the engine's internal parts. The delayed closing of the exhaust valve is called exhaust valve lag. The intake stroke. The intake valve remains open beyond the bottom dead center progress of the piston in the cylinder. The purpose of this is to allow more time for the fuel-air mixture to enter the cylinder, thereby ensuring as much charge into the cylinder as possible. This also helps to cool the engine's internal components, which can approach 3,000 to 4,000 degrees Fahrenheit at the peak during the combustion process. Compression stroke. After the intake valve closes, the upward travel of the piston in the cylinder causes the fuel-air charge to be compressed. As the piston approaches approximately 20 to 30 degrees before top dead center, ignition takes place. Exactly when ignition takes place is dependent upon engine design and varies with different engines. Ignition takes place prior to the piston reaching top dead center in order to allow complete combustion of the mixture, ensuring maximum thermal efficiency. It is on the compression stroke then that the ignition event typically takes place.